A. Is O2 oxidized in the reaction, or is it reduced? Justify your answer in terms of oxidation numbers. O2 is reduced. Its oxidation number changes from 0 in O2 to -2 in CO2 and H2O. 1 point is earned for the correct answer with an appropriate justification. B. When a sample of C₂H₅OH was combusted, the volume of CO2 produced was 18.0 liters when measured at 21.7 degrees Celsius and 1.03 atmospheres. Determine the number of moles of CO2 that was produced. N equals PV/RT equals 1.03 atmospheres, 18.0 liters, /0.08206 liters atm moles to the power -1 Kelvin to the power -1. 273.15 plus 21.7 K equals 0.766 moles CO2. 1 point is earned for the correct calculation. C. Determine the volume of C₂H₅OH in ml that was combusted to produce the volume of CO2 collected in part B. The density of C₂H₅OH is 0.79 grams/ml. 0.766 moles CO2, 1 moles C₂H₅OH/2 moles CO2, 46.07 grams C₂H₅OH/1 moles C₂H₅OH, asterisk, 1 milliliters /0.79 grams equals 22 milliliters. 1 point is earned for the correct stoichiometry for moles of C₂H₅OH and CO2. 1 point is earned for the correct volume of C₂H₅OH. D. Determine the amount of heat, in kilojoules, that is released by the combustion reaction. Q equals N delta H standard comb equals 0.766 moles CO2, 1 moles Rxn/2 moles CO2, asterisk, minus 1,270 kilojoules/1 moles Rxn, equals minus 486 kilojoules. The amount of heat released is 486 kilojoules. 1 point is earned for a correct calculation. Negative sign is not required. The combustion reaction occurred in a closed room containing 5.56 by 10 to the power 4 grams of air originally, at 21.7 degrees Celsius. Assume that all of the heat produced by the reaction was absorbed by the air. Specific heat equals 1.005 J/G degrees Celsius in the room. E. Determine the final temperature of the air in the room after the combustion. Q air equals minus Q Rxn equals plus 486 kilojoules equals plus 486,000 J. Q equals MC delta T gives delta T equals Q/MC equals 486,000 J/5.56 by 10 to the power 4 grams. Asterisk. 1.005 J/G degrees Celsius equals 8.70 degrees Celsius. T final equals 21.7 degrees Celsius plus 8.70 degrees Celsius equals 30.4 degrees Celsius. 1 point is earned for the correct final temperature. F. The boiling points of ethanol and dimethyl ether are provided in the following table. Identify the intermolecular force that is most responsible for the difference in boiling point. In terms of this force, explain why the boiling point of ethanol is higher than that of dimethyl ether. Visual. Hydrogen bonding. Ethanol can form hydrogen bonds between its molecules, whereas dimethyl ether cannot. The attractions between molecules are stronger in ethanol than in dimethyl ether. Therefore, the boiling point of ethanol is higher. 1 point is earned for identifying hydrogen bonding as the relevant force. 1 point is earned for linking the greater strength of the intermolecular forces to a higher boiling point. One method of producing ethanol is by the reaction of ethene and water, as represented below. C₂H₄ plus H2O is in equilibrium with C₂H₅OH increment H standard equals minus 45 kilojoules per mole of reaction. A chemist wants to run the reaction and maximize the amount of C₂H₅OH produced. Identify 2 ways the chemist could change the reaction conditions, other than adding or removing any chemical species, to favor the formation of more product. Justify your answer. Decrease the volume of the reaction container. There are fewer moles of gaseous product than moles of gaseous reactants. Therefore, an increase in pressure due to a decrease in volume would favor the formation of product. Lower the temperature. A lower temperature favors an exothermic reaction, leading to the conversion of reactants into product. 1 point is earned for each valid answer with justification, 2 points total.